Okay, so this is, I think, our last video as far as quadratic functions is concerned. So we talked about all the different parts of the parabola and how those parts connect together with the idea of the quadratic function and how we can use those things to draw graphs of the quadratic function. Now we're going to talk about, in this final video, some applications for quadratic functions. So nothing mathematically speaking is very useful unless it connects to something in the real world. And quadratics actually connect to a lot of different things. So in this video, we're just going to look at two examples and talk about how you might approach solving a quadratic or a story problem that involves quadratic functions. Okay, so let's take a quick look at our learning objectives for this video. There's two. One involves keywords, recognizing keywords when you're dealing with quadratic functions. Obviously, the word quadratic would be key, although neither one of the examples we're going to look at today in this video uses that word. So you also need to remember that functions that are squared or have an x squared, they are quadratic, right? So that's maybe a key symbol, perhaps. But keywords that you'll see will be words like maximum or minimum, highest, lowest, things like that. All of those keywords would involve working with the vertex. And then depending on the context of the problem, there might be keywords that indicate something related to either the X or the Y intercepts, okay? So we're gonna look at those both in this particular video. And the other thing is just solving story problems, okay? So I'll do a quick review of our lesson from last semester, where we talked about a basic 5-step approach to working with story problems. I'm not going to go in a lot of detail into that. That's not really the focus of this particular video, but I will use that approach as I go through these problems. Okay, so with that said, let's go ahead and grab our first problem. Here it is. Okay, so here's our first problem. So if you are just doing this paper or doing these notes on a piece of paper, then the first thing you should do is pause the video right now and get this copied down. Even if you have printed this off and you have your own copy of this, then maybe the first thing you want to do is pause the video and read through this and make sure that you know what's going on in this particular story problem. All right, so hopefully you've read it, because I'm not going to read it to you. That would be a waste of our time. Hopefully you've read it. So I want to remind you, when it comes to solving problems, I recommend a 5-step approach. And this is not something that I've invented. This is not something that even mathematicians have invented, although it's a common approach that math people use. But the first thing is to make sure you understand what's happening in the problem. And the key thing with that, or maybe I should say the counterintuitive thing in that, is at this first point, when we're just trying to understand, we ignore the equations and the numbers and things like that, or at least most of them, because they tend to just get in our way, muddy the water, and make it more confusing. We just want to understand the basic idea of what do all of these words tell me about some real life event. That's what the understanding part is. Once we have an understanding, then we start diving into the numbers and equations and stuff, and we start to organize the data, okay? And figure out what data have they given me that I actually need to use, and how will I use it? Have they given me any data that I don't need? A lot of times problems will have data that doesn't matter, okay? So we've got to be able to sort through that, figure out what we need and what we're going to use. Once we've got a good idea of what data we have, then we're going to develop a plan for how to solve it and carry that plan out. So because this is algebra class, our plan 9 times out of 10 involves making an equation and solving it, okay? Especially if the problem gives you an equation to begin with. Odds are you're going to use that equation somehow or another, all right? And then the final thing is you want to check your answer. And check, in this particular case, in the sense of story problems, doesn't necessarily mean plug the number back in to make sure it works, although you might do that. Really, it's more along the lines of, does my answer make sense? Does it fit with the story? Does it fit with what is happening in the physical world that these words are describing? You know, a reality check, some people would call it. And so those are our 5 steps, all right? So in this particular story, as we talk about the understanding part, the thing that I want to make sure I realize is that this is a story about a baseball player who has hit a ball So he's up the bat, he hits a ball, the ball comes off of the end of his bat and flies towards left field, okay? So if we think for a second about, here's my baseball player. All right, he's got his bat, okay? And he hits a ball, and now this ball is flying, okay? So there's my baseball, it flies off the end of his bat. And if we think about just watching a baseball fly through the air, we've seen balls fly through the air enough that we know that it goes up, eventually it turns around and it comes back down, okay? Well, over the years, scientists, physicists, mathematicians have determined that the shape of that path is basically a parabola. Now, you might get into different issues as far as air resistance and spin of the ball and whatever, but basically the path that an object takes when it's moving through a gravitational field, like the Earth's gravity, is going to be the shape of a parabola, okay? So if we think about the ground and the baseball field, there's my field, there's a spot where the ball starts this whole process, and there's a spot where eventually it's going to hit the ground. At least that's what the story tells us. So this ball apparently doesn't, he's not hitting a home run. It's not landing in the stands. The outfielder doesn't catch it. It's going to drop in for a single, whatever. But it's going to eventually hit the ground, okay? And so that's what this story is all about. Now, as we start to organize the data, we have this equation here. And what the equation tells us, or what the story tells us about the equation, is it describes how high the ball is off the ground. So that would be a distance like this, right? How high the ball is off the ground based on how far it's traveled from the end of the bat. Okay, so if right here is where we hit, based on knowing this distance right here. Okay, so if you think about graphing and you think about functions and you think about all the stuff that we've been doing in this unit with parabolas and such, functionally what I've done here is I've made a set of axes, right? Here's my y-axis right here. The ground is my x-axis right here. When the ball comes off the end of the bat, there's my y-intercept. It's going to go up, reach some maximum height, that's going to be my vertex, and eventually it's going to fall back down and it's going to land on the ground. That's going to be an x-intercept. Okay, so at some point in the organizing the data, what I want to do is I want to make sure I can connect the story to the math and algebra concepts that I've learned. All right, so if I can find this ball anywhere along the path, if I can figure out how high it is and how far it's gone, I basically know it like it's XY coordinates. We're just not using XY, we're using H and D, but it's the same basic idea. What's the height based on knowing its distance? And it says they're both measured in feet, but whatever, okay? So it wants to know, when will it hit the ground? When will it hit the ground? So in the context of the story, this is our first learning objective, recognizing key words. In the context of the story, the key concept here is it's going to hit the ground when it returns back to the x-axis. So what I'm finding here is an x-intercept. That's what I'm finding. Okay, so that's the idea of recognizing key words. Now, obviously, hitting the ground being the x-intercept, that's only a connection in this particular story. If the story was different, they would have to imply different keywords. But that's going to be a necessary thing for you to realize, is when they ask me to, when does it, or how far has it gone when it hits the ground, we're looking for an x-intercept. That's what we're looking for. Okay, so what is this distance right here? This is what we're trying to figure out. What is that distance when it hits the ground? So the height is going to be 0 when it hits the ground. What is this distance? That's an x-intercept. So if we think about the way that we solve x-intercepts, my plan is going to be set the equation equal to 0. And then either factor it or use the quadratic formula. Well, in this case, there's no way I'm going to try and factor that. Those numbers are crazy, weird, whatever. So I'm just going to use the quadratic formula. And because the numbers are crazy and weird, this is definitely going to be a calculator problem. So the first thing I want to do is recognize what my A is, 0, 0, 3, 2. what my B is, and what my C is. And then I'm going to plug those things into my quadratic formula. So normally we write x is equal to the opposite of b, blah, blah, blah. In this case, though, we're using d's instead of x's. So I'm going to make it true to my equation or to my story. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now that we've gone through this basic first 3 steps and we're ready to carry out our plan, what I would ask you to do right now is 2 things. One is to pause the video and jot yourself any notes, maybe copy my picture, whatever you need to do to make sure that you're good with what we did in these first 3 steps, okay? And then once you've done that, while the video is still paused, go ahead and try and solve it. Grab your calculator, plug these numbers into the quadratic formula, work it out. You're gonna end up with a weird, funky number. Don't be surprised by that. Although you should be able to think about what you know about baseball to see if your number makes sense, right? So if you've ever watched any baseball games, you've got a basic idea that the fence out there in left field, center field, whatever, that fence is usually, at least for the majors, it's somewhere in the high 300s. There's a couple fields where it might even be 400. So if I end up with an answer here that's like 3 feet, that probably doesn't make sense, right? But if I end up with an answer that's like 3,000 feet, that also probably doesn't make sense. So I'm thinking I should end up with an answer probably like in the 200s or 300s range, give or take. So do that right now. Go through this process, carry out the plan, see if you can solve that, and then resume the video to see if we end up with the same answer or not. All right, so hopefully you have solved this. You should have started by doing the discriminant. So for the discriminant, I just plug these 3 numbers in for B, A, and C. So I have a 1 squared minus 4 times A times C. And again, remember, parentheses matter here. And now, because those numbers are funky, I'm just grabbing my calculator. I'm just going to do this right on my calculator. And I know that might be a little hard for you to see. I'll zoom in a little, but you've got the basic idea of what I'm doing. And with a graphing calculator, remember, you can just type it in exactly the same way that it's written on your paper with the parentheses and such, because your graphing calculator knows the order of operations. So that's my discriminant right there. So that's the number that's going to end up inside of my square root. So now I'm going to have the opposite of B plus or minus the square root of that, 1.0384 over 2 times A. A was equal to the opposite of 0.0032. We might as well plug in B here. B was equal to 1, right? So this is the opposite of 1 is what that is. All right, so now I'm going to go ahead and solve that. So when I solve that, just doing the 3 parts in order, the opposite of 1, that's going to be equal to -1. The square root of this, well, I'm going to have to do that on my calculator again. So I'm just going to do square root. And then remember on your calculator, to get the previous answer, if you push second and then the negative sign, it shows the word answer. And that just takes that number and pastes it in there. So there's my square root. Wow, that's a big number, but that's okay. Plus or minus 1.019019136. Okay, I suppose if you round that off, it's probably not the end of the world. And then down the bottom, I'm going to have 2 times this. Well, I knew 2 times 32 is equal to 64. So I'm thinking 2 times this decimal is just going to be a -0.0064, I'm thinking. Okay, so now I'm going to have to add and subtract those. This is interesting. We're going to get 2 answers, which seems weird. Should the ball hit the ground twice? Well, I mean, I guess we might think about it bouncing, but that doesn't seem right. I don't know. Let's just see what happens. I'm getting ahead of myself. So if I do a -1 plus that number, again, I'm just on my calculator here. I'm just typing this in. -1 plus that number right there. Notice how I just used the arrow button to highlight it, and then it pasted it for me. So that's another option you can do. And I'm going to divide that by the -0.0064. So one of my options is -2.97174. There's one of my options. For my other option, -1 minus, and again, I'm just going to use my arrow button to get that number, highlight it, push enter. And then I'm going to divide that by negative 0.0064. And I get 315.47174. Okay, so I got two answers. Now let's think about this for a second. In the context of the problem, this answer, these numbers represent the distance the ball has traveled. I'm zoomed in a little too much, you can't see. The distance the ball has traveled from when it came off the player's bat until it landed in left field. That's what these numbers represent. So the first one is a negative 2.9. So negative 2.9 would mean it basically was like a foul tip, right? It like went and it landed right there. Okay, so in the context of this problem, that's not my answer, because it doesn't say that it was a foul tip and that it went backwards. It doesn't say that. It clearly says that it lands in left field. So this is not going to be my answer, just simply based on the context of the problem. So this must be. And again, if you think about what I was saying before, in a Major League Baseball park, it's very reasonable to think the ball could travel 315 feet and then still end up on the ground in left field. So I think there's my answer. It has traveled. If I would just go ahead and round this off to the nearest foot, probably. If the problem tells you exactly how to round it, then follow what it says. Otherwise, what makes sense? And so it probably makes sense, if we're talking about a baseball game, to say that it traveled 315 feet. That probably makes sense. Okay, so there is my first story, right? All right, let's move on to the second one. So this is a slightly different problem. So we're going to do the same thing. I'm going to start by asking you to make sure that you read this and you have it in your notes. So if you don't have this document printed off, then pause the video and copy this into your notes. Even if you do have it printed off, pause the video and take some time to read this. Okay, so hopefully you've taken the time to read this. The first thing that I'm going to ask you to try and do is to give a summary. Because remember, we talked about last semester, understanding the problem. You know you understand it if you can summarize it. And summarize it without using numbers and equations and things like that. Just, you know, how does this problem connect to real life? What's a quick summary of what aspect of the real world does this problem tell me about? All right, hopefully you've given some thought to that. If not, pause the video and give some thought to that, right? That's an important step in this. But what we have is we have a company that makes light bulbs, and it says when it makes light bulbs, it has certain fixed and variable costs. Okay, so that might be knowledge. What that means exactly, I don't think, after I read this, I don't think it really matters what a fixed cost or what a variable cost. I don't think that matters to this problem. I think we can still do this problem without knowing what that is. But if you're really curious, this is something that comes up in economics. When you are running a factory or company or something, you have certain expenses that don't ever change. Like, for example, you've got to, pay rent for your building or something like that. That's something that's the same every month. It never changes. That's called a fixed cost. Variable costs are things that change depending on how much stuff you do. Like, so if I'm building light bulbs, then if I only build a couple light bulbs, I don't need very much glass. But if I build lots of light bulbs, I need lots of glass. So the money that I spend to buy glass to make my light bulbs, that's a variable cost, because the amount of money I'm going to spend depends on how many light bulbs I make. Okay, so that's all those two words mean. Again, I don't know that we have to understand that to solve this problem. If we read the rest of it, it tells us this equation right here, which notice it never says that it's quadratic, but we see that there's a b squared, so that tells us that it's quadratic. We know we're working with parabolas. That equation will tell us how much cost is associated with producing light bulbs. So C is the cost that we're spending on light bulbs, and B is the number of light bulbs that we're making, okay? Now, what it wants us to do, so there's my understanding, okay? It probably is important as part of your understanding to make sure you understand what the question is. The question they're asking me is how many light bulbs to minimize the cost, All right, so if we think about this, I'm just gonna very quick draw just a very, very quick sketch, not an actual graph, but a quick sketch. I see that my A value is positive. So I know this is a parabola that opens up. and I have a really big y-intercept. My y-intercept is 800. So if I was to think about a graph for this thing, I've got a graph of a parabola that looks something like this, okay? Now, exactly where's the vertex and how high does it go and whatever, I don't know that yet. Maybe it crosses the axis, maybe it goes down here. I don't know that yet, but I do know I have something like this. And so notice when it's asking to minimize the cost, right? The parabola is the cost, the C of B, that's the same as my y value. My y value is the parabola. If it's asking me to minimize the cost, it's talking about the vertex. That's where the minimum happens, is at the vertex. So this question is basically asking me to find the vertex. So my data, what I need to do is remember, how do I use a quadratic equation to find the vertex? Well, the way that I do that is recognize what A, B, and C are. So perhaps I might start by rearranging it to get it in the correct order, the standard order, you might say. So there's my standard order. So I can see my A is 0.25, my B is -10, and my C is 800. So now I'm starting to get my data organized. I found what those things are. The other thing that I'm going to need to remember is that in order to find a vertex, there's a formula. Normally we write x equals. For this problem, we're using b's instead. So I'll stay consistent with the problem. Maybe not, because that's going to get confusing with this b. So let's not do that, because they're two different b's. Let's just stick with x. All right. So x is the opposite of b over 2a. Right? So I think we've got all our data organized. We've got our equation, we've written in the correct form, we found A, B, and C, and we remember that this is the formula that I use to find the vertex. So I've got all my data organized. I think my plan is going to be to solve this formula, right? To find the vertex. So let's do that. Let's make and carry out our plan. So if you would, go ahead and pause the video and find that vertex. All right, so hopefully you started by taking this equation and plugging in the values that we have here for A and B. B is -10, A is 0.25. If you simplify that, the opposite of -10 is +10. 2 times a quarter is a half. And if you divide 10 by a half. Now be careful here. I'm not dividing 10 in half. I'm dividing it by a half, okay? So what that means is I'm going to end up with an answer of 20. And you can verify that on your calculator if you want to. So x is equal to 20, all right? Now, technically, I could stop right now, because notice the question wants to know how many light bulbs. And the light bulbs, that's going to be the value of B, and B is what I'm plugging into the equation, so that functions the same way as my x, just like the C is functioning the same as my y. So once I know the x value for the vertex, that's how many light bulbs I should make. So the answer to this question is we should make 20 light bulbs. That's my answer. Minimize cost. I think I spelled minimize wrong. I think I need some more letters in there, but that's okay. Minimize. That's probably better. Cost. There we go. 20 light bulbs will minimize the cost. Now, one quick side note, that is my answer. I'm done with this problem. If the question asked you, what is the cost associated with making 20 light bulbs? Or what is the minimum cost that they might have to spend? Then we would have to take 20 and plug it back into the equation to figure out what that cost is. But for this problem, we don't have to do that. I think we're all done. All right, so that takes care of this video. We've talked about some keywords like minimize, maximize. Those are going to involve finding the vertex. Concepts in the story that connect to x and y intercepts. As a side note with this one real quick, if they asked me for the y-intercept, do we recognize that the y-intercept is exactly where the ball hit the bat? right? That's my y-intercept, but that's not here nor there, okay? So keywords and how they connect to the story, that's part of our learning objective. And then to actually be able to answer the question. Those were our learning objectives. And so I think we've got those covered. Thanks for watching. Have a good one.